Before introducing motors, we need to master a little basic electromagnetic knowledge. This is the simplest closed DC circuit consisting of a battery, wires, and a small light bulb. It is best to add another switch to control the disconnection of the circuit. Close the switch and the circuit is on. There is an electric current flowing in the wire, and the small light bulb lights up. The direction of current flow in the wire is clockwise from the positive electrode of the battery to the negative electrode of low potential. If we install the battery in reverse, the circuit will still be on. It's just that the direction of the current in the wire has become counterclockwise. If we replace the small bulb with a spiral coil and connect it to the circuit, because of the magnetic effect of the current, that is, a wire with an electric current will generate a magnetic field around. Coiling the wire into a spiral coil will superimpose the magnetic field. Exhibits a stronger magnetic field. Through the current from left to right, according to Ampere's right-hand rule, hold the energized solenoid with your right hand or fingers pointing in the direction of the current. The end pointed by the thumb is the end pole where the energized coil generates the magnetic field. If we change the direction of the current, the direction of the magnetic field generated by the energized coil also changes. We insert an iron core into the spiral coil. It can greatly increase the strength of magnetic induction. So we got a piece, an electromagnet that can be generated at will and change the direction of the magnetic field. It has the same properties as permanent magnets. The same pole repels each other. Different poles attract each other. Now let's change the shape of this electromagnet. Let it rotate around its axis and call it a rotor. At the same time, an arc-shaped permanent magnet is placed on each side. The two permanent magnets point the N and S poles to the rotor respectively. An immovable, call it a stator. Give the rotor an incoming current from the left side. It generates a magnetic field. Due to the repulsion of peers, just deflect it slightly. The rotor will rotate half a circle in an instant and stopped because opposites attract. If you want the rotor to continue to rotate, you need to change the direction of the current in the coil. To switch the direction of the pole of the rotor and changing the direction of the current, you need to use a commutating plate and a brush. The copper commutator plate is fixed on the central shaft of the rotor, connected to the coil. The brushes are under the action of springs, close to the commutating tab, and the position is fixed and connected to the power supply. After turning on the power, we let the current flow from the right side of the brush, flowing into the coil through the commutating tab. Then it flows out from the left brush. The coil generates a magnetic field. The rotor rotates. When turned to the horizontal position, the rotor continues to rotate due to inertia. At this time, the brushes on both sides switch the commutating plate they contact. Reversal of the direction of current in the coil. The poles of the rotor are also reversed. Because of the presence of commutators, the direction of current in the coil, it can automatically complete the switching while the rotor rotates, thus constantly changing the direction of the magnetic poles. Keep turning. This is the prototype of the brushed DC motor. However, it should be easy to spot its problems. Remove the uneven speed. After disconnecting the power supply, the rotor will most likely remain horizontal under the attraction of permanent magnets on both sides. At this time, when the power is on, the rotor cannot rotate without intervening in external forces. Therefore, the motors of the two permanent magnet stators we actually use on the left and right. The rotor is usually an odd number of coils, such as 3 or 5 coils. In this way, there is no balance position for it. When the current enters from the right brush, 2 of the coils are S poles to the outer magnetic poles. The other is the N pole. At this time, the rotor rotates counterclockwise and constantly switch the direction of the coil's poles to keep turning. When the current enters from the left brush, 2 of the coils are N pole and the other is S pole. This is the principle of brushed DC motor rotation and switching direction. We will also introduce the most basic brushless electric mechanism type. Contrary to the brushed motor just introduced, brushless motors usually use permanent magnets as rotors, and the electromagnet made of the coil core is used as the stator. Brushless motors also require Hall components to sense the state and position of the rotor. Now, let's simplify its control circuitry and connect to the power supply. At this time, the 1 and 3 Hall elements near the end pole of the rotor are activated. 2 of the Mohs tubes in the control circuit are on. Current flows through the AC coil. The coil is N pole to the inner magnetic pole. The C coil is the S pole to the inner magnetic pole. The coil repels the rotor. C coil attracts the rotor. This pushes the rotor to rotate. As the rotor rotates, at this point, only the No. 3 Hall element is activated. Control circuit toggle switch. That's it. The control circuit constantly changes the power on of the coil. The rotor can keep rotating. This is the principle of the inductive DC brushless motor.